Hello everyone, welcome once again to my channel. Now in this section we have a question still on random variable, and then the question is asking for us to find the expectancy and also the variance for the random variable of x, where it is a PDF. So we are given a function f of x being equal to 1 over 2 exponent minus x to the power minus x. So and we are given a condition from 0 less than x, which is also less than 4. So now let's look at how to solve this question. Now it is a random variable, so basically it is a continuous variable, because the question says that it is a PDF, so it's a continuous variable. Now how do we get the expectancy? So given that expectancy here is being equal to so expectancy mu is equal to the integral, let's say, from a variable a to that of b, and then we have x here being multiplied by the f of x, the x in this case. So in this case our e of x here, mu, is equal to the integral we have from 4 upper limit, 0 lower limit, which are the conditions here, and then x here multiplied by f of x, which is just half e exponent minus x here, the x in this case. So from here we just bring 1 over 2 out, and then we have 4 here, 0 here, and then we have x here multiplied by e exponent, that's the x. So if you look at the integral we have over here, we have two variables in this case. We have x and then also e exponent minus x dx. So what we have to do is to use integration by parts in this case. So using integration by parts, integration by parts is given by the integral of u dv here being equal to u multiplied by v, and then minus the integral that is from some that is the conditions, and then we have v du in this case. So per what we have over here, you can see straightly from here that u here is equal to, that is comparing this integral here to what is in the integral over here. If you compare that, you realize that u here is just x. So if u equal to x, what do we need again? We need du, right? So in this case we need du, because solving this integral should be equal to the whole of that. So in this case we need du, so we have to differentiate u here. So du dx here will be equal to 1, because if we differentiate x here, just 1. So in this case we have du here being equal to the x, right? Okay, now if du equal to the x, what do we need again? Now we have u, we need v, right? And then also so over here we are given the v here to be e exponent that, yeah. So if you compare that to the whole of that, u is that, and then the v is that. So v here will be equal to the integral of the v, where from the comparison we realize that the v here is equal to e exponent that. So when we substitute that into it, we have e exponent negative that, and then what we do here is to go ahead and then integrate. So integrating this, we are just going to get so integrating this, what we do is that we are focused on the exponent. So what we do is to drop it. So when we integrate negative x here, we are going to get we differentiate rather, sorry. So over here we are going to get negative 1. So negative 1, then we drop it, right? So we have negative e exponent minus x here, e exponent minus x. So that will be, now that will be the value for v in this case. So if that is the value of v, then which means that from here, writing the whole of that, then we are just going to have, remember we have 1 over 2 outside already, so we have 1 over 2 in this case, and then also we have into bracket, remember it is u multiplied by v. So u in this case is x, then multiplied by the v in this case is negative that. So let's bring the negative outside here, and then we have e minus x here, and then minus, remember it is minus the integral of v du, and then the integral of v, and then v is still negative here. So when we have negative and negative, this changes to positive, and then you have e exponent that, and then it is du. Du is equal to dx. Du here we did that, du is equal to dx, so we have dx right now. So from here we have 1/2. Let me write everything very nice. So x here, e to the power minus x here, and then remember it's from 4 and then 0. Now we still have this in the integral, so we still have to integrate this. So integrating that, when we integrate that, we are just going to get negative, so negative comes down, and then minus x here, and then it's with respect to dx, and then remember it has some limit, sorry, the limit 4 to 0, so 4 and then 0 here. Good. Now from here we have 1/2. So since we have negative and then negative here, what we can do is to just substitute negative out, so that we can just have x here, e to the power minus x here, then 4 0 here, then plus e to the power minus x here, then 4 0. So what we are going to do here is just to substitute. So we are just going to substitute this limit into it. So the first one is 4, so we have 4 e exponent minus 4 here, that is substitute 4 into it. The next one will be minus 0 e to the power 0 here, and that will be the first part, which is this side. And then to the other side we have e exponent minus 4 minus e exponent 0. Remember everything is multiplying the 1/2 outside here. Right now when we compute the whole of that, that is putting everything together, we are just going to have that. So you can just punch that on the calculator, and then you have the answer to be this. So that will be the expectancy of that. So therefore we can conclude that the expectancy, which is equal to mu here, is just this 0.45427 there. So that will be the expectancy. So in this case, the variance in this case is just the integral of s squared f of x here minus the mu that we got over here, so the mu squared here, that. So in this case we just have from 4 to 0, and then we have s squared here, and then multiplied by 1/2, and then we have e exponent minus x here, then dx, in this case minus mu squared. So from here we can just substitute 1/2 outside. So we substitute 1/2 outside, then we are left with the integral of 4 here, 0, s squared here, e exponent minus x here, dx minus mu squared. The mu squared is just the value we got for the first part. So now from here we still have integration by parts, and then we still have to solve it using integration by parts. So in this case you realize that using the integral of u dv here being equal to u multiplied by v minus the integral of v in du here. So we have in this case, comparing that to that, u here is just s squared. So if u is equal to u equal to s squared, then which means that we also need du. So du here will be equal to just differentiating that will be 2x, remember, divided by dx. So in this case our du here is just equal to 2s plus 2s dx, and then we need dv. Dv here from the integral is just giving us e exponent minus x. So if we want to find what v is, what we have to do is to find the integral of that, right? And then this is just going to give us minus e exponent minus s. You just drop the differentiate this, which is negative x here, which is -1. You drop it and then you repeat the same thing. So that's how to differentiate that. So since we have this, then we can go ahead and then put that into the variance. So we have 1/2 here, and then so we are just going to get everything as u multiplied by v. So u, we have to be s squared multiplied by v. V in this case is negative e exponent that. So so let's put that one here, e exponent that, and then from here we have minus the square root of v, which is that. So it's just going to be positive the square root of e exponent minus x here, and then remember it is du, and then du we have to be 2x dx. So what we can do is to just bring the 2 out, because we are multiplying by 2x. So we bring the 2 out, and then we are left with just x here, and then dx, because it is 2s dx. So we just substitute, we just brought the 2 out, and then we have e exponent minus ss dx here. So realize that still it is incomplete, the integral is incomplete. Remember it's 4/0 here, 4/0 here. Now with this side we can just substitute 4 into x here and then do the computation. Then we have for this part, but for this part we still have it in the integral, right? So we still have to do another integration by part again. So doing another integration by part again just for this side. So we are doing it just for this side. So let's consider that part only. Remember the variance is just that, and then minus mu squared. So doing for this part only, just this is a constant, so let's just leave it leave it where it is, and just let's consider this one. So for that, then e exponent s dx here. So from here we use integration by part again. So then again we have u being equal to x, because we have x here. We can either bring the x here, it doesn't matter. So we have x e to the power s, and then du will be equal to dx here, because we need du, and then also our dv here is just e exponent that. Remember we are still using the integration by part, which is u dv being equal to u multiplied by v minus the integral of v du. So this is u, and then we have our this is u, and then we have the v to be that. So u multiplied by dv, and then we also need v from the formula. So v will just be the integral of that, yes, which is just going to be just drop the negative, so differentiate this, we get -1 e exponent that. So that will be v, and then from there we just substitute everything into it. So substituting the whole of that into it, then we have this to be u multiplied by v. So u is x, and then this time v is just that. So we just have negative x e exponent minus x here, and then remember we have minus the integral of v du, but v is already negative here, so we just have positive here, and then we have the integral just that. Then du, remember du is just equal to dx. So in this case we can just go ahead and then solve the integral straight without doing another integration by parts, because we only have e exponent s here. So we just go straight to the point. So we have minus x, then that. So integrating that, we are just going to get negative e exponent that, and then we still have it from 4/0. Remember all of this is just representing this part, just this part. So we are just this part, so we just substitute that into it. So writing everything again, then we just have the variance of x here, and then remember we just have this part already there, so 1/2, and then this time okay, let's maintain the negative inside, so negative x squared, and then e to the power minus x here, remember it's for 4 0, and then for this part we have plus 2. Remember, all of this part is representing the integration we did over here, so this was the results we had here, and then so it will be 2 here into bracket minus x e exponent minus x, and then it's from 4 to 0 minus e to the power minus x here, and still 4 to 0. Remember, the 2 multiplies the whole of that, but then again the 1/2 is also affecting the whole part. Okay, so from here, remember, it's minus mu squared. Okay, so from here, just computing the whole of that, what we are going to do is just put 4 into it, so we have minus 4 that squared here, and then e minus x here. So okay, so another thing we can do is that since we have negative, and then we have negative throughout, let's bring one negative outside for all of them, and then when we bring the negative outside, we are just left with x squared e exponent minus x here, 4 0 plus 2 here, and then we have x e exponent minus x here, 4 0, and then plus e exponent minus s, 4, and then 0, so affecting the whole of that, then the mu squared. So what we are going to do next is just substitute 4 into it, then minus substituting the 0 part. So you do for this part, you do for this part, and also do for this part also. So when you do everything, you are just going to get everything. So from here, just solving this part, just this part without the mu, because what we are going to do is to just put the 4 here, square that, e to the power minus 4 minus, then you do the 0 part, and then you do that same for all of this part. Remember, the 2 is affecting all of that, so just do for that part, and then when you do everything for this part, you should get 0.761895, and then it will be minus the mu. Remember, the mu we have 0.45427 squared, and then when we compute everything, we should get that to be 0.55553. yeah, so that will be the variance of s in this case, and that will be the variance for x in this case. So thank you very much for joining me in this section. I hope this section was helpful. Please like, subscribe, and also hit the notification bell to be notified anytime we post a new video. Thank you very much for joining me in this section, and I will see you in the next session, which will still be on continuous variables, but then it's also in a different question, in a different way. Okay, bye.